Good afternoon. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and in this afternoon's session, I'm going to talk to you about the differences between engineering and engineering technology, because you have college curriculums out there that will have engineers and engineering technologists work in the same discipline. Let me give you an example. You have civil engineering technology, mechanical engineering, and mechanical engineering technology, electrical engineering, and electrical engineering technology. Now, one must understand, when you go to college and you major in engineering technology, there is overlap with engineering. I went to Temple University, and the engineering technology students took the same courses and had the same instructors as engineering students. Now, some other courses aren't that way, or some other schools aren't that way, and you also have to look at accreditation. Now, when it comes to engineering technology can be accredited by ETAC of ABAT, which stands for Engineering Technology Accreditation Commission, or ATME, which has to do with applied engineering and technology management. Now, for the most part, when we deal with engineering technology as a whole, what you do is basically implement the ideas of an engineer, because an engineering technologist is not relied heavily on math. It's relied more on application. However, you do take some of the same math. Now, when you deal with engineering is more of a theoretical area. They deal more with design, they deal more with putting out the ideas. Now, when it comes to actually going out into the real world, some employers recognize engineering technology and engineering. It just depends on where you went to school, who you work for. Now, again, when you deal with engineering technology, you're basically an implementer. When you're an engineer, you're an innovator. Now, when it comes to the curriculum is on applying current knowledge and practices to the solution of special technical problems and standard design problems. Students engage in discipline topics early in the freshman years, where when you talk about engineering, you go through all your math, and a lot of your innovations are basically developing new methods of analysis and solutions for open-ended, complex, and unique design problems. Most of the discipline when it comes to engineering occurs when you are a junior or senior. Now, when it comes to engineering technology, a lot of your information is lab-based, or we say hands-on, because new graduates would mostly likely enter into fields of construction product design, development, testing, technical operations, technical services, and sales, where engineering, your graduates, but most will probably aspire in entry-level positions in conceptual design, systems engineering, product research, or development. Now, going back to engineering technology, your graduates are readily accepted to graduate school. They often pursue graduate study in construction and facilities management, fire protection and administration, engineering management, business administration, or some similar program. But when it comes to engineers, some of them may go on to grad school, some of them may not. But if they go on to grad school, they're basically utilizing their time for advanced study in engineering. Of course, just like I mentioned before, when you deal with engineering technology, you're more likely to get hands-on laboratory training when it comes to testing. You could be working in the construction field, or you could be working utilizing circuits or machinery as a electrical engineering technologist or mechanical engineering technologist. Whereas an engineer, you're going to be focused on design and research and product development. Now, here's one of the big differences between engineering technology and engineering when it comes to education. Now, the coursework when it comes to engineering technology is based on algebra, trigonometry, calculus, and college level sciences. Now, the level of math is not as in depth as you would have in engineering programs, because engineering technologists, they focus on applications of the engineering disciplines in the freshman and sophomore years of study. Now, students planning on subsequent graduate studies often take additional mathematics as part of their undergraduate preparation, whereas when you get into engineering, the coursework includes multiple semesters of calculus and calculus-based theoretical university-level science courses during the first 2 years, followed by engineering science analysis and design in their junior and senior years. Now, as I mentioned in a previous video, you can actually take, as an engineering technology student, the same calculus-based physics, calculus, math, 1, 2, and 3, differential equations, statistics, as engineers do. Now, I would actually encourage engineering technology students to do so. Why? Because when you get a degree in engineering technology, when it comes to licensing requirements or going to grad school, if you have that engineering math in your undergrad, it's a lot easier for you to go to some states that will allow engineering technology students to take the licensing tests and get into grad school. But overall, when it comes to engineering and engineering technology, there is an overlap, because when it comes to both fields, they're both needed. Now, I would always say when it comes to an engineering team, you start off with a scientist, a researcher, a technologist, and a technician. Now, let's take the scientist out of the equation. Usually the engineer is the one who's doing all the research, and a technician. Now, a technician usually has a 2-year degree in engineering technology, preferably in construction, industrial technology, mechanical engineering technology, electrical engineering technology. Your 2-year engineering technology student is known as an engineering technician. Your technician is the one who actually does most of your testing. Now, right in the middle, you have your 4-year engineering technology student, and that person is basically the liaison between the testing and the design work. Now, one good thing I like about engineering technology is if you take the math as an engineer, you can speak the language of an engineer, and you can do the work of a technician. Very valuable. In fact, when it comes to engineering technology, taking the engineering math will also allow you to take a lot of your major courses in your freshman and sophomore years as well. Because when you go to some of these universities, like a Purdue, like a University of Maryland, like a Michigan or Penn State, or even a Temple University, engineering students have it rough because a lot of the courses are called weed out courses, like your statics, your physics, your calculus. Those courses are your foundation courses to what you're going to see in your junior and senior years. Again, as I mentioned before in this video, you get a lot of your undergraduate courses known as core requirements to shape the foundation of your engineering program. In every engineering discipline, they take the same courses. It doesn't matter if you're going for industrial engineering, you're going for civil engineering, mechanical engineering, electrical engineering, doesn't matter. All engineering students take the same courses, so you have to be strong in your math in an engineering curriculum. Now, engineering technology, it just depends on the school. But for the most part, you're going to take 2 semesters of calculus in engineering technology, 2 semesters of algebra-based physics. As an engineering technology student, go on and take engineering calculus, go on and take calculus-based physics, because it will give you an upper hand, in my opinion, even over an engineer, because you're actually doing the hands-on, where engineers are basically utilizing theory. Now, if you're an engineering student and your school provides laboratories, I know in the civil curriculum there are a lot of laboratories, it'll help you get a better understanding of the theory because you're actually applying it. A good engineer knows how to apply the theory. People who work in academia who've never been out in the field, they make pretty bad engineers because they don't really know what's going on out there because they've been in the academia bubble for all their lives. Now, I had one professor named Dr. Bronenberger from University of Maryland, good teacher, but he didn't understand the real world. So, when it comes to going to college, picking a STEM program in engineering or engineering technology, my suggestion is to look at both of those curriculums. And you have to find out what suits you. Now, if you're going into engineering technology, see what states allow you to take the licensing examinations, because it's very important that you get a license or some type of certification like a Six Sigma lead certification, because that will also help your resume, because a number of employers are looking for certification. But again, look at engineering or engineering technology. If engineering technology suits you, go with engineering technology. If engineering suits you, go with engineering. But overall, both fields are very rewarding and challenging. Now that concludes this segment of engineering and engineering technology differences from the mind of STEM. And on this channel, I'll give you a daily dose of science, technology, engineering, and math. Now, if you want more controversial topics, check out the 411 Talk Zone radio show, and also check out 411 Talk Zone radio show on Blog Talk Radio. Now, if you can't find me on Blog Talk Radio or YouTube, simply check me out on Facebook and Twitter. Again, thank you for listening to this segment of the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. Please have a wonderful and gracious day. God bless you.